Hey guys, and welcome back to another video on the channel. In today's video I'm going to be taking a look at the Specialist Multiple Choice 2024 External Exam Paper 2 Tech Active. Yeah, that's pretty much about it. Pretty much in this video here I'll be going through these multiple choice questions. If you have any questions at all during the video, leave something in the comments and I'll try and answer it as soon as I can and try and timestamp your question. But otherwise, let's just get straight into it, okay? So, question 1. Given that z equals -2 plus 3i is a root of this particular cubic where z cubed plus a z plus b equals 0, where a and b are real numbers, another root is. So this one is actually a pretty easy question if you know your complex numbers quite well, okay? So if you have a polynomial or something, if you have one complex number as a root, its conjugate will also be a root. So if z equals a plus bi, then z equals a minus bi would also be a solution. So all we've got to look for is pretty much the conjugate in these answers here. So the conjugate of this guy would be -2 minus 3i. And we can see it straight there in A. Okay, so that's the first answer straight away. And we don't have to check the other answers because that's just a general knowledge thing you have to know with like this particular question here. Okay. Alright, so let's take a look at the next one. So, question 2. Rounded to 2 decimal places, the z value used in the calculation of a 95% confidence interval for mu is. Okay, so z score for 95% confidence interval is 1.96. Okay, so again, another question we actually just have to know it. No real thinking really of those ones. Those ones are just like, alright, know your stuff or don't know your stuff pretty much. Otherwise, you could take a guess pretty much with each of them. Alrighty, let's take a look at question 3. So this might be a pretty quick video if they're all like this, hopefully not. Alright, given a equals I plus k and b equals 2i plus k, determine the cross product. Okay, so if you cross two vectors together, you'll get a vector perpendicular. So if you wanted to, you could actually, if like you weren't sure how to do the cross product, you could dot your answers here with these guys and see which one gives you a dot product of 0 because it is perpendicular. But that probably would take a bit long, but so would doing the cross product, okay? So if we're doing A cross with B, pretty much you make a determinant of a 3x3 matrix where the top row is going to be I, J, and K, and the bottom rows are going to be the first vector A, so in that case here it'll be 0 because there's no I component there, plus one lot of J, and plus one lot of K. And then for B, we have 2I, 0J, and 1K here. Now you've got to make that into 3 2x2 matrices, okay? And it has to follow plus, minus, plus, okay? So the first matrix you'll make will pretty much be, alright, cross out this, cross out that. It'll be this matrix here, multiplied by the thing that gets crossed over here. So that first matrix will be, I'll just write down here. So it'll be positive 1, 1, 0, 1, I. Then it's going to go minus. Then you pretty much cross out this row here. So that's your next matrix, 0, 1, 2, 1. And that's going to be your J component. And then plus, because it's going to go plus, minus, plus. This matrix here, the 0, 1, 2, 0, K. Alrighty, now all you got to do is find the determinant of each of them, okay? So here, what we've got to look for is things in common in each of them, okay? So we can see here they all have a positive 1 at the front here, okay? And we can check this is going to give us a positive 1. So all you have to do is multiply these two numbers together, so that gives you 1, and multiply these two numbers and subtract it from that, so it'll be minus 0i, okay? So 1 minus 0i, so that's just going to be I for that first component. Same here, multiply these numbers, so that's 0, and then subtract multiplying these numbers, so minus 2, and that's got a negative in front, so that's going to be a positive 2j, okay? Now we look for the answers with positive 2j, so it's got to be between C or D straight away, okay? There's no other option straight away. These ones are incorrect because they've got negative j. Now here, multiply these two numbers, so that gives you 0, and then you go minus multiplying these two numbers, so minus 2k, okay? So it's going to be I plus 2j minus 2k. So the correct answer here is C, okay? So that one's probably the trickiest out of the questions so far. The first two were just general knowledge facts, pretty much that you have to know with the syllabus. This one here was a bit of a calculation one here, okay? Alright, let's move on to the next one. So if you have any questions about those first three, leave something in the comments and I'll try my best to answer them. Okay, question 4. The mass of biscuit packets produced by a company is normally distributed with a mean of 250 grams and a standard deviation of 1.5 grams. The distribution of a sample mean mass of these biscuits packets is formed using a repeated random sample of 5. The mean and standard deviation of this sample are. Okay, so when you're taking a sample, you're basically using the central limit theorem pretty much. So everything will turn to a normal distribution regardless of what it previously looked like. However, the average or mean is going to pretty much be the same as the average of the sample. Okay, so here, when they're saying the mean and standard deviation, if they don't have 250 as their mean, we know it's incorrect straight away. So it has to be between C or D straight away, because those are the only two answers that have 250 there. Okay, and they've said mean first, so we have to assume these guys are the mean, so it can't be A or B straight away. Now, the standard deviation, so the standard deviation of a sample is the standard deviation of the population divided by the square root of the sample size. Okay, so in this case here, the standard deviation is 1.5 and the sample size n equals 5. So you have to divide that by the square root of 5. Okay, now if you chuck that into your calculator, because remember this is a calculator exam, you're going to get about 0.67. So the correct answer here is going to be D. Okay, alrighty, let's move on to the next question. Alright, question 5. The equation of a plane is 2x minus 4z minus 8 equals 0. Determine the point where the plane intersects the z-axis. Okay, so likewise with functions, if you're looking for an x-intercept, a y-intercept, a z-intercept, the other quote-unquote variables have to be equal to 0, because on the z-axis, x equals 0 and so does y equals 0. So here, our plane only has x, y's don't really exist, so subbing in y equals 0 doesn't make anything change. But if you chuck in x equals 0, you can solve pretty much for which values we have for z. And we can also look here in the answers. See the first two coordinates, the x and y are 0 for each of them. So that's another way you can tell if you're not sure about with an intercept there. Okay, so here we just chuck in x equals 0. So that disappears. So we're left with the equation negative 4z minus 8 equals 0. Move the minus 8 to the other side, so negative 4z equals 8, and divide both sides by minus 4. So z is going to be 8 divided by minus 4, which gives you negative 2. So the correct answer here is going to be B, because it's 0, 0, minus 2. Okay, alrighty, let's move on to the next one. Alright, so question 6 here. So question 6, two concurrent forces represents in the polar form F1 and F2, as we can see there. We've got the magnitude and the angle of them respectively. Determine the magnitude of the resulting force. Okay, now when I'm doing ones like this, what I like to do is put them out of polar form, add the x and y components together, and then pretty much find the length of it. Because the magnitude of the resulting force is the length when you add those two vectors together, okay? So what we've got to understand here is pretty much this first one. Let's say that's the point. F1 is 120 degrees. Meaning that's looking like this here, because that's like 120 degrees there, and that's F1 there. Now here F2 is negative 160, so that's looking about down here, so F2, okay? So straight away we can see our x component is going to be quote unquote negative, and some of this will cancel out with one another, okay? Now if you're putting stuff in quote unquote component form again, you need to multiply pretty much the length, and you need to go cos for the x and sine for the y. So here, if we're trying to put this pretty much in quote-unquote component form, F1 for the I component will be 1.21 cos 120 degrees I. Okay, and then for the y component, it's going to be positive 1.21 sine 120 degrees j. Okay, and we'd have to calculate those values for both of them. Okay, now I'm going to move this diagram because I don't have enough room really. So here, then you have to go, F2 is the same thing, so it's going to be 1.30 cos negative 160 I plus 1.3 sine negative 160 j. Okay, now you've got to chuck these into your calculator. Okay, now obviously I'm not going to be able to show you on the screen here. So if you chuck in these first values here, so if we go, I'll just calculate them by hand right now because I don't think I left the values down when I solved it previously. Cos 120. So this should give you about negative 0.605. Okay, And this value here, 1.21 sine of 120, should give you about positive 1.047. And don't forget an I and don't forget a J there. Okay. This value here, so if you go 1.3 cos, and don't forget the minus 160, this should give you negative 1.2216 I, and this value here, so if you go 1.3 sine negative 160, you'll get negative 0.44 approximately. Okay, so all you've got to do now is add, oh, what's going on with the highlighter there? Let's try that again. You've got to add that, and you've got to add, oh, the highlighter did it again. You've got to add that and that, because we're looking for the magnitude of the resultant force, meaning we add the forces together. So what is the net force acting on this thing? So when you add them together for the x component, so the yellow plus the yellow, you should get about negative 1.8266 I, and for the blue, you should get about 0.6032 J. Okay, now you just find the length of that. So the length of that, this is pretty much your quote-unquote net force, okay, in component form. The magnitude of the resulting force, aka this, is we just got to find the length of this. So you go square root negative 1.8266 squared plus 0.6032 squared, all under a square root. And if you chuck that in, you approximately get, let's just check here, 1.92. So the correct answer here is B, 1.92. Okay? Alright. If you have any questions about this one here, I'd understand because it's quite calculator heavy. But the concept isn't actually that hard. It's just very calculator heavy, okay? Alright. But otherwise, yeah, leave a timestamp if you have any questions about this one. But let's move down to the next one. Okay. Now, this one here was a little bit tricky, question 7. But it's actually quite clever how they answer it, okay? So all we got to do is read the question. They're not asking you to solve for it. They're asking for the number of roots, okay? So to determine the number of roots, w to the power of 8 equals 1. That can be expressed in the form a plus bi, where a and b are real positive numbers. Now, a lot of people would go looking, where is 8 as a solution, okay? Because if you're taking, so if you take a cube root of a complex number, you have 3 solutions. If you have a fifth root of a complex number, you have 5 solutions. So if you're taking the 8th root of a complex number, which is what we're doing here, you would have 8 solutions. But look at the wording here. So here, number of roots. So the correct answer would be 8 if they're including all of them. So here, what we've got to imagine is, alright, the first solution would be at that guy there. Because if you what's the 8th root of 1? That's 1. So if you go pretty much 360 divided by 8, you're going to have a total of 8 solutions separated by 45 degrees each. So you have something roughly like this. Now, this is a little bit of a trick question, okay? Look at the wording here, specifically at the back. In the form where that and that are real positive numbers. That changes everything, okay? Pretty much what that means is B cannot be 0 and neither could A. So that eliminates that one, that one, that one, and that one. And here they have to be positive, which eliminates that one, and that one. So the number of roots that can be expressed in this form where that is positive and that is positive is only 1. So the correct answer here is B. Now that's a good question, but that's also a tricky question. A lot of people would just guess that one, I reckon, because they wouldn't notice that bit at the back, okay? Hopefully you won't now when you do your exam, okay? Alright, question 8. So t is a random variable. The random sample of 4 values of t is collected and used to produce an approximate confidence interval with population mean of 3.3 and 4.1. Given the three of the sample values of this, the remaining sample value is etc. Okay, so here we just need to work out what that 4th value is. So here, because they've given you the confidence interval, that means the average has to be in between both of these values here. So if you go 4.1 plus 3.3 and divide by 2, what does that give you? So go 4.1 plus 3.3, divide by 2. So the average is 3.7, okay? So a lot of people would pick B, but that's not what it's asking. They're asking for the data point to give you that. So what that means is 3.4 plus 3.6 plus 3.9 plus the thing we're trying to find, so we'll say x, divided by 4, has to give you 3.7. So all we have to do is solve for that. So multiply both sides by 4. So 3.7 times by 4. So you have 3.4 plus 3.6 plus 3.9 plus x equals 14.8. So subtract all those values now. So 14.8 minus all of that there. And that shall give you your answer. So here if we chuck that in our calculator, so 14.8 minus 3.4 plus 3.6 plus 3.9 close brackets, that gives you 3.9. So your correct answer is actually D. Okay. Now that's not a hard question. If you don't rush it. If you rush it, it can be a bit tricky. Okay. All you've got to do is read and just think, all right, what have you been given? What does the confidence interval mean? What's this random sample represent? Okay. All right. So question 9. A random variable x has an exponential distribution with a probability density function given by here. Given that the probability between 0 and k is 0.5, determine k. Okay, so this should be pretty easy. So if you integrate between 0 and k of a fifth e negative x over 5 dx, that will give you a half there. So all we have to do is solve for this. So if we integrate that guy here, we have to divide by the derivative of the inside function. So the derivative of that guy there would be negative a fifth, okay? Because if you integrate e to the something, it just remains e to the something. So here, your integral will be negative e negative x over 5 between 0 and k. Now we do chuck in the 0 with this one here because it will actually make it quite significant. So if you chuck in the k, you'll have negative e negative k over 5 subtract negative e to the 0 equals a half. Anything to the power of 0 is 1. Therefore, this here is going to be positive 1. So if I move the positive 1 to the other side, I have a half subtract 1, which gives you negative a half. So we can rewrite that as this equals negative a half. Divide both sides by negative 1. That gets rid of the negative sign here. Now all we're doing is using basically this formula from methods, if I can learn how to write it, to solve quote unquote for k. So at the moment we have an exponential form, aka this equation here. We want to put it as this equation here. So that means it's going to be pretty much quote unquote negative k over 5 natural log of a half. Okay. So all we've got to do now is times both sides by negative 5. So k is going to be natural log of a half times by negative 5. Then we just chuck that into our calculator because it's a calculator exam. Okay. The solve ends don't necessarily work on these guys here. Sometimes you have to do a little bit of work here. But again, pretty tough multiple choice question. Now if you chuck that into your calculator, you should get about 3.47, which is D. Okay. Alrighty. Let's take a look at the last question now. So question 10. Acceleration of an object at time t for 0 to 2 seconds is given by acceleration is 2 over t plus 1. Given that the object is initially at rest, its velocity time graph is. Okay, so here, initially at rest, when t equals 0, v equals 0. Okay. If I want to go from acceleration to velocity and time, I know acceleration is the derivative of velocity with respect to time. So all I've got to do is just chuck that into there and quote unquote just integrate both sides with respect to t. So that means velocity, if I have some room to actually write it. So velocity would be the integral of 2 over t plus 1 dt. Which will turn into, velocity is 2 natural log t plus 1 plus c. Okay? Now here we can chuck in the initial condition. When t equals 0, v equals 0. So if I chuck in t equals 0 and v equals 0, I get 0 equals 2 natural log of 1 plus c. Natural log of 1 is 0, so c is also going to be 0. So your graph, or your function, is just this guy here. And since it's a calculator exam, you can actually physically graph that. Now here, how we can tell which one's correct straight away is see how it's a positive log, and there's no other negative signs. It's not going to be A or B straight away. So it's actually going to be between C and D. Okay. Now, if you didn't want to graph it, how you could check is if you could chuck in x or t equals 2, you can see what value you're going to get with each of them. Okay, so if I chuck in t equals 2 in here, I'll get 2 natural log of 2 plus 1, which is 3. Now that is not equal to 4. So I know D is incorrect straight away. So I know C is going to be the correct answer. But a way you would check that on the calc exam is just graphing that on your software. Okay. But yeah, that's about it for the exam pretty much here. I'd say it's a pretty tough one. Not impossible, but tough. But if you have any questions about the ones we did today, leave something in the comments. Try and timestamp it as well. That way I can find them quite easily. But I'll see you in the next video.